Good afternoon, everyone. On behalf of agricultureinformation.com, I'd like to invite the speaker, Mr. Sushanth Masana, who will talk about driverless automatic tractors. I now request the speaker to begin. Thank you.
Hi, thank you so much. This is Sushanth Masana, CEO at Farm Sathi. So, I would like to give you a quick introduction about what we do and how our journey has gone towards building electric autonomous tractors. Want to show you why we need electric autonomous tractors and then take you through the solution of our units. So, back in 2020, during COVID times, I was walking with my grandfather and I couldn't last more than 2 hours. So that was a turning point for me. I worked in a couple of electric companies and also did my master's from IIT. All my projects revolved around robotics. So thought, why don't I put my expertise to use and solve first for my grandfather. And a few serving statistics here are that average age of Indian farmer today is more than 55 years, and not even 1 in 4 of the prime working age are employed in agriculture, and they don't want to as well. Around 40% it was employment in agriculture, and 2004-5 fell down to 23%, and now less than 15%. They either better off, they feel they are better off working as drivers or watchmen or any other odd jobs that are available in the cities, nearby cities, rather than going into the farm and working there in their own fields as well. So they abandon the fields and coming out to the cities. So this shortage in labor is what's leading to inefficient farming. What do we mean inefficient? It's the lack of timely maintenance, the weeds, lack of timely controlling of weeds or sprays and fertilizers, irrigation. So there are a lot of aspects that one has to maintain when it comes to growing crops. All of these are not maintained, and it requires a lot of manual efforts. So this shortage is raising is uh, what actually arising, giving us a lot of weeds and pests. Untimely maintenance is what's causing minimum losses of 33%. If you say you don't do it within the times in the time windows that we have, and farmers face around 33 to 40% in their losses, and they're spending 43,000 crores in terms of mitigating these losses. That is, paying higher wages. They're paying either paying getting a lot of diesel based tractors, second hand ones. So they're spending around 40,000 crores in a few horticulture belts of these Andhra, Maharashtra, Telangana. So with the help of our robotic solutions, so we can reduce drudgeries by 90%, increase profits. So what does our tractors do? This looks like a regular tractor. I'll show you the autonomous one as well, but we'll get to how we had pivoted into tractors. And these tractors are all electric and can perform a lot of operations, starting from sowing with the help of an earth auger, can dig holes, and then cultivator, rotavator, orchard sprayers, different sprayers. Then cutting how your harvest from one place to another. Let's say you have an intercrop of super napier or any other grass, all of that can be uh, cut, then put it in a trailer, can transport from one place to another as well. So all of this is possible with around our tractors are somewhere around, we start from 12 HP, the robots, and goes up to 18, 22 HP. They're all less than 20 kmph speeds, and but have possess a good amount of power performance in terms of the field. So I'll take you through the video, the journeys of how we have developed. So this is the first. I'll take you through the video of the working of the tractor. Resharing my screen. So this is how the tractor looks like. And once we start the operation, it's a high precision GPS based navigation. A person has to sit and operate first and drive this, and it will map the entire field. It will record the GPS coordinates highly precise around 3 to 4 inches. Usually you have 3 to 4 meters in your mobile phones, but you just got, you can see two antennas over here on the top, and there is another base station also that's giving it always it's giving a correction data. So it gives an accuracy of 1 to 2 inches at the sensor level, but it translates to around 3 to 4 inches on the tractor level. So this is one of our earliest versions. Now we have models as well in these tractors. The regular tractors are going good. Regular tractors is that you don't have these GPS sensors. You can either sit and drive. There's no clutch here. You can see. So this is just an accelerator without a brake, or sorry, without a gear. And some models, of course, have a gear as well. So reason being, one person should be able to take care of at least 30-40 acres. So once the cultivator or a rotavator is finished, then people move to sprays. So this is a sprayer attachment. Both have different maps, and again, person has to once drive this in terms of horticulture. But if it's row crops, what a customer can do is that he can just give the entire boundary, but you have to start from the right of the sowing pattern. So sowing pattern, the cultivator, all of that has to happen through our tractors only. Only then you can perform in row crops. But when it comes to plantation crops like citrus, banana, mango, and other orchards, all you have to do is just sit and drive once. And these are all mostly perennial or at least 2 years, 3 years crops. So the plantation pattern remains the same. And you can drive n number of times once you press the start and stop buttons. So it takes good turns. You can control all of that remotely as well. So this is a stop button through remote, and you can, if you want, you can directly start as well. Remote is basically a safety feature. If you are someplace else, how do you make it stop and start if it's stuck somewhere? If you're unable to sit on the tractor, so these are all these. So people have loved this. This is a bit of uh, an expense when you want to upgrade your regular tractor to an autonomous one. This cost, let's say, for example, our tractors cost somewhere around 4 to 6 lakh, and it will be an add-on of another 3.5 to 4.5 lakh of the GPS systems to the tractors. So we are trying to bring the costs down, but more or less it will be somewhere around 3.54 lakhs for the autonomous upgrade. We have very precise control on the steer and the uh, drive as well, motor drive as well. So these can be equipped on diesel tractors, but diesel tractors you cannot control the throttle in the sense of accelerator, and you cannot control it remotely. So in our case, we control that. So hence we'll achieve full autonomy in our case. Right. Now I'm going to show you the journey of Farm Sathi, how we have started and where have we reached, why did we pivot, all of that is quick video. So till now what we are saying is why is it necessary, and now I'm going to show you why did we pivot from small robots. People say that robots will solve the issues, But in agriculture, robots are a bit early in India at least, and even in the entire world, there's no successful robotic deployments yet that actually beat the tractors industry. So I'm gonna show you a video of our where we can assess the success and you can also see the journey. So yeah, sharing my screen quickly. So this is how this is back in my village, West Godavari district of Andhra Pradesh. We started off this as a small workshop inside an oil palm field. All of this was just a project. We did not register a company. It was just a project basis. Then later we registered because this is a much bigger problem that has to be solved for the entire fraternity of Indian farmers face. So in that, after 6 months of hardships in that small workshop based out of the village, we've built this. These are again autonomous versions of small robots. You can do the spraying part of it, but the power was not sufficient. Did not work more than 5 to 10 minutes. Later, we raised some funds, moved to area NAM based out of Hyderabad. Area is one of the best agri-tech incubators in India. So they helped us pivot. They helped us do the trials, testing. This is in the Rajendra Nagar. We will have huge, uh, you know, agriculture land over there for testing and trials. And then we pivoted multiple times. You can see the changes in versions over here. This is another version. So this version finally worked. You can see the dynamics of the tractor here. We have a patent on this as well. This is a smaller wheel on the front, and the rear wheel has got the bigger one. And there's dynamics in this, all ready to track this. You can see a linkage system over here. It can pull good amount of weights. So this worked pretty well in the fields, but still it has its own challenges, which I explain. We made this autonomous as well. So this is another version that came later with the higher HP. Previous ones were around 6 to 8 HP. They worked well in the fields, but then people wanted to carry more uh, water, more loads. So we had then slowly increased the HP to 12 HP. We did some trials and testing for material movement. If you want to move some fertilizers, etc., from one place to another, you can use this when you're or construction equipment. But again, all of this was well, it has its own challenges. For example, let's say we have these agriculture robots. How do we transport them? So that was one of the biggest issue. You need another transport vehicle to move from farm to village or village to farm. And as a form factor, it's a smaller one than the tractor. It's around 2.5 feet. Hence, you cannot do more than half an acre or 1 acre in a day. So that's about the two biggest drawbacks. And then third one is about financing options. So how do we open financing options was a challenge. There are no certifying agencies yet readily available in India for certifying them, and banks do not accept or give finance options without the certifications. So certifications was a bottleneck on the third front. And fourth issue was that these are all remote controlled and autonomous versions. You need some skill set. It's just a 2 to 3 days of skill set, but farmers were very clear that today there is going to be one worker, tomorrow there's going to be a different worker. How do we train and retrain everybody? And that's about how we pivoted from small robots into tractors. So when we go to a tractor, they get the form factor like a tractor, and you can cover more area. You don't need a different vehicle, sit on the tractor, go to one place or another. And finally, there are certifying agencies who can certify electric tractors now. So we get our finance options opened up as well. So I'll show you the version that's most safe, stable, and these these variants we've actually sold in farms. I think we did 4 5 units of sales, but we recalled all of them because of these shortcomings that I've explained earlier. But the performance was decent. It's not that we don't have a market for it, but just are early right now. Market is too early, and maybe 5 to 10 years down the lane, these are the necessary. But till then, tractors and autonomous tractors will take the stage. You see, one can sit on top of it or stand in a shade and drive them. It's got a PTO just like a tractor at the back, so you can attach multiple implements. So it can carry payloads of about 800 kgs. So only one machine which can have both implements without changing, interchanging. So there's sprayer on top, then the rotavator at the back. So usually you have to interchange between them, but in this versions we don't need to interchange them. These are sprayers. Multiple orientations are possible with the sprayer, either for row crops or high rise crops. All of those are differently possible. So I'll take you through uh, our latest electric tractors, which are manually operated and don't need any diesel. So you can see how happily she is able to drive. There's no clutch and there's no hassle of learning in it. It's just simply like a EV scooter. But yeah, in the latest models, you have a gear. So you put it in the right gear, and just all you have to control is uh, a simple throttle and a steering. It's slow. You don't need impulsive reactions as well. These are earlier versions, so bit of aesthetics have improved from these from this version to this. So something 1.5 year old version. Then later, we've got much better ones. You'll shortly see the depth of the tillage as well. So it has got good power in terms of tillage too. This is a bed maker. So uh, once you operate on it, it'll make a bed of around, I think it'll make a furrow of around 6 to 8 inches. So if you want more, second pass is needed. So on the second pass, you get a 1 feet or 1.2 feet. So you can see the depth of it now. So that's a robotic model as well on the side. So that's all about us. So if you have any queries, questions, please.
Okay. Thank you, Mr. Sushant, for the presentation and sharing the videos. So now I'll take up some questions.
Sure.
Just one second. Okay. So some the few basic questions which you might have answered already. So how do driverless automatic tractors work and what technologies power them?
Yes. So they work on the drivetrain is an electric motor based drivetrain, while the navigation part of it in the terms of steering part that is based on GPS RTK systems. So it's high precision GPS.
Okay. So you're not using AI in this?
So AIs are inbuilt in this. So for detection, if there is a obstacle in the front, if it's a human or a plant or a animal, it stops accordingly. And these are all add-ons. Then you have rerouting the path. Once let's say this is a permanent obstruction that is newly added, like a heap or a fertilizer heap, then the rerouting happens with help of AI's map. So yeah, these are the two features that are there. Some are an add-on, some as inbuilt features.
Okay. And okay. So when did you start manufacturing this?
So we started the company in 2020, but tractors and all of that we came in 2025 Jan or 2024 December. That's when we started with electric tractors. Before that, 3 4 years we were into only R&D of robotics.
Okay. And what are the key advantages of autonomous tractors, even conventional over conventional tractors?
Yeah. So with diesel tractors, conventional ones, you need 50,000 rupees of expenses per year, and on top of that another 50,000 to 80,000 on maintenance going forward. Then you need a skilled operator to sit on top of it. So all of that is heavily costing farmers and burning their pockets. So with this autonomous tractors, farmer himself can take care of his farm without the need of a skilled driver attending the tractor or anything. Just plug it and switch it on, off, take care of the obstacles. That's it. And you don't have to put in diesel maintenance as well into it. So all of these expenses are all gone now.
Okay. And can driverless tractors perform operations like plowing, sowing, spraying, and harvesting with high accuracy?
Yes. So this has an accuracy of around 3 to 5 inches, depending upon the openings in terms of 5 inches for horticulture crops because they have good shade. Well, but it can go up to 2 to 3 inches when we come up on to the row crops.
Okay. Mm, like, can you share any like the numbers on this for how many hours that way?
Sure, sure. So we have multiple variants in this. Let's say we take 15 HP tractor or a 25 HP tractor. All of it depends upon the battery pack and the capacity of the motor as well. So more or less for rotavator, that and I mean mainly rotavator, it will come down to somewhere around 3 to 5 hours. For the bigger ones, the rotavator is on the higher side, so number of acres will increase, but the backup will be somewhere around 3 to 5 hours. And if the moisture is good, if you're doing it the right time, then 6 hours as well. So usually people work in the morning for 4 5 hours in average, wake up 8 to 12, and then charge it for another 3 to 4 hours, and complete another 5 hours job. So like that, they're able to do good number of acreages in a day. So for rotavator, it can do around 4 to 5 acres, while cultivator you can do up to 7 acres, 6 7 acres, and that too non-stop. In cultivator, it's uh, I think you'll get a backup of around 7 to 8 hours. Then mulcher is a weeding, uh, attachment that you it takes care of all the weeds on top of the soil, removes all of it, makes it small pieces without touching the or without scraping the soil. So that gives a backup of around 8 9 hours. Then sprayer, it gives 3 to 4 days, not an issue with the sprayer. So all of these can cover multiple different ranges, more or less somewhere around 3 to 4 acres with rotavator. Then uh, with cultivator 5 to 6, with mulcher 6 to 7, then sprayer I think can cover up to 20 acres. So yeah, that is about the ranges.
And how do these tractors ensure safe operation in fields with people, animals, or obstacles?
So this AI will actually detect. It's a computer vision based system that actually detects, and if there is a living being in front, it will stop. And if it's a permanent obstacle, it will try to reroute and also notify the user. So these are the two safety features in autonomous tractors. But regular tractors, all you have is just your throttle, and immediately as you remove the pedal off the throttle or the accelerator, it will immediately cut off the power. The motor shuts down, so your tractor immediately comes to a halt. There are brakes as well in it. These are all manual brakes, but EM brakes are also there for the autonomous version, electromagnetic brakes. So these are the safety features, key safety features.
Okay. And what is the cost expect? Sorry, what is the expected cost and return of investment for farmers adopting this technology?
So regular tractors are priced somewhere around 5 to 6 lakhs, while autonomous one need an additional 3.5 to 4.5 lakhs. 3.5 to 4.5 in the sense, You have multiple variants in the autonomous stack as well. So all of those variants with camera, without camera, with a base station, without a base station. So if there is already a farmer, or if you are purchasing in 2 to 3 units, all of you in the same field, then all of the costs will come down as well. So it will come to 3.5 to 4.5 lakhs, add on to the about 5 to 6 lakhs of regular tractor of ours, regular in the sense our electric manual tractor.
Okay. And are driverless tractors suitable for small and fragmented land holdings in India?
Not exactly for small landholders, but it's perfect for even small landholders who want to become entrepreneurs, who want to provide CHC services, custom hiring services, or annual maintenance services. So we have a franchising model where farmer can buy our tractors and we bring them the annual maintenance acres. So they can take care of their 1 2 acres of land and also become service partners to nearby landowners. So up to 40 50 acres they can take care with these autonomous tractors, and they can earn around 6 to 7 lakhs of income apart from their agricultural income with these tractors services per year. So that's the target that we are focusing on, rather than directly selling it to individual farmers, but selling it to individual farmers who also want to become entrepreneurs through our franchise model, earn income through delivering services in nearby farms.
Okay. And how do GPS, AI sensors, and machine vision work together to improve field operations?
So this AI and vision, they don't actually give me field operation feed, but this is an add-on system that gives me an higher accuracy. So let's say sometimes you don't have GPS when it's very cloudy, or when there is no signals on the satellites. So then AI and vision systems will actually take over and give the guided path. If it is required to spray, or if it is required to do any operations in such heavy. But in our case, for usually the people don't use tractors or do any operations in such high cloudy situations. So it's a add-on, but it's not rightly currently available with our systems in terms of directly navigating through AI or computer vision. But it's a complementary feature. That's a safety only feature for now, but it's a add-on as well for complete navigation when there is no GPS available.
Okay. And what are the biggest challenges in adopting autonomous tractors in India? And how can they be addressed?
So electric tractors have been in the industry. Just the regular electric tractors were in the industry from past 5 years, but BIS or any standards of certifications have been launched only a year or so. So similarly, for autonomous tractors, there are no regulations yet. So we need regulations and certifying bodies who can certify these autonomous tractors, and hence finance options can be provided after the certifications are done. So these are the challenges in terms of adoption on a bigger scale. But tractors, electric tractors, though they have released testing procedures and standards for autonomous hardware, autonomous upgrades. There are no norms yet. So if we get those norms out, then it'll be easier.
Okay. And since affordability is a major concern for Indian farmers, do you see the tractor as a service or shared autonomous machine model becoming
Yes.
more viable than individual ownership? And
Yeah. Yeah.
what business model do you believe will driver drive faster adoption?
Right. So in the entrepreneur franchising model I was talking about, a farmer can easily earn somewhere around 4 to 6 lakhs, even after spending all his, even after detecting all the operation expenses, even after he hires somebody to operate the tractor. He takes care of the nearby 40 50 acres of land. he can earn easily 6 to 7 lakhs, and that is a good income for a farmer. While this approach has to be formalized in terms of FPO level or a CHC level. And the roadblock again is a finance option. But yes, once this finance option is cracked down and there are a few FPOs that has adopted it, yes, this will scale much faster. The entrepreneur model where farmers can buy our autonomous tractors and deliver services to nearby farms. The share model will pick up much faster, and we have already done it. We have done a couple of pilots with our electric autonomous robots, the smaller ones. It gave good results, but for farmers to adopt it, yes, these are the challenges: the finance, and they wanted tractors. So again, in autonomous finance is not yet possible, but we're trying to get it done through some private NBFCs for the autonomous upgrades. But the tractor will be financed through different regular banks. So these are the different modalities that we're working on. So if even if one goes through, yes, this will bring in mass adoption.
Okay. So now we have the last question.
Mm.
As the founder and CEO of Farm Sathi, what inspired you to develop autonomous farming solutions and what has been the biggest learning from working with Indian farmers?
Yeah. So this we started this out for my grandfather, and he had faced a lot of troubles in setting up his coconut, cocoa, and oil palm farm, and wanted to help him out. Was not possible by me. I couldn't give him a helping hand standing beside him. So I thought I should build something for him and the farmers fraternity who were facing all of them were facing the same problems of labor shortage and lack of untimely maintenance. So that's what actually motivated me to get into autonomous farming. And I have a background of ITBHU and other robotics startups as well. So I thought, uh, I'll build something for him, solve this problem for all of them.
Okay. And your career background, can you let us know about it?
Sorry?
Your career background.
Okay. Uh, I mean, I'm a mechanical engineer. At my graduation was at IIITM Jabalpur. Then worked at Capgemini for over 1.5 year. And after getting the corporate experience, I thought, this is not yet what I want to do. Not into IT. I thought I'll put my I want to learn more in mechanical, and so I've put my efforts towards GATE and went into ITBHU. I worked there with a couple of companies, clean electric. That was retrofitment, EV retrofitment startup back then. Now it's making electric batteries. So I come from an EV background, and also all the projects revolved around a lot of automation, robotics during my graduation at IIIT or masters at IIT. So I uh, kind of have all the expertise and started this out because of my background. Yeah,
Understand. So that was good to know. I don't see any more questions. So now we have come to end of question round. On behalf of agricultureinformation.com, we'd like to thank you for the presentation and sharing the videos and answering all the questions in depth. So we'll be ending this meeting now. Have a good evening.
sure, sure. Thanks. You too have a good day.